Okay, well, then I will go ahead and I will close the poll. Is that all right? Did everyone get a chance to respond? Manage, and we'll go ahead and close the poll. All right, and we will get started on today's lecture content here, okay? And I know you guys just had your computers open or phones open to respond to the poll, but my request would be, okay. I prefer you guys just kind of follow along with the things. You can take notes on paper or whatever, and then answer the questions that we've got put up on here. All right. Okay. So we'll start off basic data structures. Okay. This should be mostly review from Stats 20. All right. But it's good to review, okay? So we'll start off talking about vectors. Atomic vectors, generic vectors, which we might call lists, okay? And these are kind of your most important things, the most important objects that this is our primary way of interacting with R and storing data and storing values in R, okay? All right, question 1. What's the main difference between an atomic vector and a list? Main difference between an atomic vector and a list. This should be like right away. Yeah. Yeah, in an atomic vector, all the values are the same data type, okay? And lists can allow for things of different data types, okay? So atomic vectors, everything in there is the same data type, okay? And so we've got, there are 6 fundamental data types in R, and we primarily interact with only the first 4, okay? So you've got type logical, you've got type double, type integer, and character, okay? Those are probably the 4 that you interact with the most, but there's also complex, for complex numbers, like imaginary numbers and stuff on the complex plane, and then also raw, which is kind of how R stores things internally in memory as these kind of hexadecimal values. But pretty much, we'll just focus on the first 4, and you can use type of to see exactly what data type it is. So we use type of to see the data type. Mode is going to be kind of the operating mode, and so it says double and integer are the same. Storage mode is actually an old thing that we don't really use anymore, but it's pretty much the same as type of. Storage mode is kind of from R's ancestry, which was S. I don't know if you guys know the history of R. It used to be created in Bell Labs. Bell Labs created C, and then they also created S. And then later on, R got adapted. Was an evolution from S there. Okay. All right, so we've got 2 numeric types, type double and type integer, and R actually kind of switches between these types very quickly. It kind of often throws things up into type double very quickly. And we use type double anytime we've got a decimal point, okay? Floating point numbers is a type double, and integers are integers, right? Do you guys know why it's called type double? Okay, well, so it's type double because there's also a type single that doesn't exist in R, but if you come from a programming language like C, there's different ways to represent a decimal value, right? So you got real numbered values that in the real world, or I don't know, the real number line, there's an infinite number of numbers, okay? But you obviously can't represent all infinite numbers with finite memory, and so the computers use 64 bits or 8 bytes to represent a number, and so you can represent about 2 to the 64th power unique values, and that's going to be type double. Back in the day when memory was a little bit more tight and expensive, they said, well, we don't need this much precision, okay? Let's only use 32 bits, 4 bytes, okay? And that was a single point precision, okay? And that would be kind of like using, most of your calculators, like when you buy them at the store, can show like 8 numbers, 8 digits from 0 to 9, but it would be like buying a calculator that only showed 4 digits, and maybe that was good enough, okay? But before then you had slide rules and it was good enough to get you to the moon. So anyway, there's type single that's not used anymore and nobody cares because we all have like 4 gigabytes of RAM on your phone, and so that's what we have. But type double is for floating point numbers, and we've got type integers. If you want to specifically say this is an integer, you can use the capital L, and that will make something an integer. And if you use the colon operator, like 1 colon 100, it also creates an integer vector. All right. So here, by default, if you just say I'm making the numbers 1, 2, and 3, R creates them as type double. Okay, meaning it's capable of holding decimal values. Anything with a decimal value like pi or 7.2 or anything like that is also going to be type double. Here I say 1L, that's an integer. 1L is going to be an integer, and if you use a colon operator, it will also be an integer, right? And so these are just kind of these functions: is.double, is.integer, is.logical. These are all the types of things that say, you know, is the data type of a certain thing here. All right, we've talked about the difference between atomic vectors and lists. And atomic vectors are homogeneous, meaning that everything in the atomic vector has to be of the same data type, whereas a list can have different data types, okay? And so if these are one-dimensional things, we'll call the atomic vector the atomic vector. As soon as we make it more than one-dimensional, then it becomes a matrix, right? And so if you've got a matrix, has to be homogeneous, meaning everything in the matrix is like an atomic vector that all has to be of the same data type. So if you've got a matrix of integers, as soon as you put in a type double number in there, it's going to turn the entire matrix into type double, okay? And as soon as you put a character value in there, it's going to turn the entire matrix into type character. Okay? If you want this two-dimensional structure that looks like a table, but have different data types, like you want one column with numbers and one column with characters, then you've got to create a data frame, okay? And a data frame is stored internally like a list, which allows for it to have the different data types, right? And so you can have one section that's integers, one section that's doubles, one section that's character, and things like that in your data frame, okay? And the list can contain any other object, including other lists, right? And then if you want something higher than 2 dimensions, okay, so 3-dimension or something, R can do it with arrays, but it's only available for this atomic vector homogeneous type of data, okay? So we'll call these arrays. So you can have 3-dimensional arrays, 4-dimensional, 5-dimensional, n-dimensional arrays here. All of these objects, okay, whether they are lists or atomic vectors or, you know, a lot of objects can have attributes, okay? Attributes are stored internally as a list, okay? It's a list of, it says metadata, just extra information that you just kind of want to tack on to the data or the vector that you have, but not actually be the data itself, right? So it's kind of just like, you know, you have when you take a picture, that photo contains metadata, like when the photo was taken and stuff like that, okay? And that's possible with digital photos, right? But if you print it out, that information is kind of lost, right? And so actually, I don't know if you guys remember this, maybe it was way before your time, but it used to be that cameras would actually print the date the photo was taken in the like lower right-hand corner of the photo, right? And that was like a way to store that. But if, you know, it's also a little bit unsightly, okay? And so if you don't want to store this thing as part of the actual data, you store it as attributes and stuff like that, right? Okay, so do you guys remember how to access attributes? ATTR, good, right? Great. And there's also the attributes function, okay? Here's another question. How is a matrix different from a data frame? So we already covered one of the answers there. And how is a matrix stored internally versus how is a data frame stored internally? Yeah?
I might be wrong, but isn't a matrix a vector with the dimension attributes and then the data frame is a list?
You are exactly right. You are not wrong. Yes, a matrix is an atomic vector with dimension attribute, okay? And a data frame is stored as a list, okay? And it's got some extra attributes there as well, right? And then we'll talk about the factors, but yeah. Well, anyway, how is a factor stored internally in R? You guys remember this? Yeah. As an integer vector. All right, good. You guys have remembered your stuff from Stats 20. So good for you, right? All right, so let's talk about attributes, right? So here is a data frame, just the head of the data frame trees, okay? So R has some built-in data sets. Trees is one of them, right? Trees has rows, columns, girth, height, and volume, and things like that. Okay, you guys remember the attributes of a data frame. So if I say, give me the attributes of trees, what attributes does a data frame have? All right, here's a question. Does a data frame have a dimension attribute? All right. We'll all hold out our hands, all right? So if you think data frames have a dimension attribute, give me a thumbs up. And if you think data frames don't have a dimension attribute, give me a thumbs down. So we'll all hold out our hands sideways, and we'll go 1, 2, 3, and then we'll either go up or down, all right? And there's no pressure. I don't care. It's just, all right, are you guys ready? Okay, dimensions, dimension attribute yes or dimension attribute no, data frames. Okay, ready? 1, 2, no one's holding out their hands. What's up? Okay. Ready? 1, 2, 3, go. Oh, you guys waited for me to go. All right. Okay, so let's take a look. When you look at the attributes of a data frame, there's actually no dimensions attribute, right? This is surprising because when you come, whoops, what happened here? When you come to R and you say, give me trees, oops, treeing, I don't know what that is. Okay. Trees, it looks like this, and then you can say, what are the dimensions of trees? And it looks like that, 31 rows, 3 columns. But if you say, what are the attributes of trees? There's no dimension attribute, okay? So what is R doing? It's looking at the names, saying how many names do we have? We've got 3 names, which means we've got 3 columns. How many row names do we have? We've got 31 of them, which means we've got 31 rows, okay? So the attributes for trees are the names, the row names, and then the class that says it's a data frame. Okay? Because as far as attributes go, it's just a list, okay? The attributes of a data frame, attributes of any object is just a list. So you can throw in any additional information, right? You can just say, I want to assign a new attribute, okay? ATTR trees. And we're going to just assign this character string. This data frame is about trees. And we're going to store it into some attribute that I've just made up called info, okay? And then I can get that later, right? So it's just, this is not something you normally do, but the attributes is just a list, so you can do stuff like this. It's not against the rules, although, nobody really does this. Okay. All right, let's talk about matrices, okay? So as we said earlier, a matrix is just an atomic vector, okay? So here I've created the vector 1 through 10, okay? And so this is an atomic vector, and if I say what is its class, it's going to say it's an integer vector, okay? And then if I take this atomic vector and I just throw on a dimension attribute, suddenly it becomes a matrix, okay? So I can just say take M, assign the attribute, the dimension attribute, make it 2 by 5, okay? And it says, all right, here is a 2 by 5 matrix, okay? And you can say, all right, what are the attributes of M now? And it's going to say there's dimension attribute. What if I say here's M, 1 through 10, and I ask what are the attributes, what would it come back with? So if I asked attributes M right here, what do you guys think it'll say? All right, well, all right, so here's M, okay? M is 1 through 10. Here, let me remove M first, okay? So M doesn't exist, so we're gonna say M is gonna be 1 through 10. Okay, so here's M, attributes of M. Let's see. Okay, there's no attributes, it's null, right? Okay, so if I say take M, assign attributes, we want to assign the dimension attribute, we're going to say we want 2 by 5, boom, now M is a matrix, and I can say what are the attributes of M, and it's going to say you've got dimension attributes, it's 2 by 5, okay? Here, I can take the attributes dimension and I can overwrite them with null. What will this do? Yeah, question. Or answer.
It'll make it an atomic vector.
Yeah, it'll kill the dimension attribute, right? So now the attributes of M, the attributes of M are null again, okay? And M just prints out as an atomic vector. So I've just turned my matrix, made it back into an atomic vector. Okay, so here's M, and again, you can just, let me just go back, and we're gonna set the dimension attribute to be 2 by 5, and M looks like this. I can go back and I say I want to go 5 by 2, okay, and it just reshapes M accordingly, okay, and so now I've got a 5 by 2 matrix. And we can see, this also clues us in how R fills out matrices. It goes down the columns, right? So 5 by 2 goes 1, 2, 3, 4, 5 down the column, 6, 7, 8, 9, 10. Whereas over here it goes 1, 2, and then 3, 4, 5, 6, 7, 8, 9, 10. Okay, and again, and so a matrix is just an atomic vector with the dimension attribute. Now if you try to do something illegal, right, like make it a 3 by 3 matrix, it says no, right? It says, you got an object of length 10, and this is wrong, right? 3 by 3, I need 9, okay? So M is unaffected. It's not going to change the dimension attribute there. Okay, and then so as soon as you do that, it becomes a matrix, and you can ask what is the class M, and basically class M, to come back and say it's a matrix, it needs to have a dimension attribute of length 2. Right? A matrix is 2-dimensional, so the dimension attribute has to be of length 2. All right. So this is like review, or it is review, but also maybe you're just like, oh yeah, maybe I forgot, maybe I remember all of this. Okay. All right, and then the other thing we've got is the array. Okay, so an array is basically a matrix but higher dimensions. So you can have, so here's a 3-dimensional array. I've got the integer vector 1 through 12, and for the dimension attribute, I'm giving it a length 3 vector. So I want a 2 by 3 by 2 array. So I want 2 rows, 3 columns, and 2 layers or 2 sheets. Okay, so you can think of it, now I'm making this 3-dimensional kind of rectangular prism structure. Okay, and so I've got 2 rows, 3 columns, and then this is the comma comma 1, that's your first layer, first sheet. And then I got comma comma 2, that's your second sheet, okay? And then I could add a 4th dimension, and what would that do? I would have like 2 blocks, and then if I do another dimension, then I would have an additional, I don't know, hypercube or something, I don't know, 5-dimensional things. It's hard to picture. Okay. And you can do it this way, or you can make it using an array. I would say in R we're not we don't typically use arrays very often, but arrays do appear very frequently. I don't know, like in Python, they use arrays all the time. The ND array in Python, they might call them, like if they're big, they call them tensors, okay? And they're commonly used for like neural networks and stuff. And so there's like a TensorFlow, which is all about just multiplying these big n-dimensional arrays. R can do the same thing, but for whatever reason, less commonly used in R, more commonly used in Python here. All right, so we talked about this already. A data frame is stored internally in R as a list, okay? And it's got the class attribute is data frame, but if you ask the type of, how is it stored internally, it's stored as a list, right? If we investigate this a little bit more closely, so here's trees. It looks like this, and we can ask the attributes of trees, and indeed it's got what we've seen already, the names, the class, the row names. If we want to print it as a list, we can say print.default, okay, and print it as a list. And now we see the internal values of trees. We see we have girth, which is length 31, height, which is length 31, and volume, which is length 31 vectors. Okay, so we got a list of vectors. Each of these vectors is length 31, okay? And so we have that. I can take trees and make a copy of it, okay? And TT will also have this, but if I say, what's the class of this? So this is a copy of trees. I can take this and I can throw in a null here, okay? And that's going to kill the class attribute, okay? And so if I ask, what's the class of this copy of trees, it's going to say it's a list now. And if I say, well, print out the list, okay? Now it prints out as this, okay? It looks like a list. And so for a data frame, everything has to be of the same list. Like if I take trees, okay, and if I say trees $ girth, and if I want to throw in something into make it length 32 by throwing in the value 30 or something like this, it says you're not allowed to do that, okay? But TT, I've got rid of that data frame attribute, okay? And so I can do TT $ girth and throw in a value here, okay? And it works, okay? Because it doesn't have that same restriction. So now this has a length 32, okay? Now if I try to turn this back into a data frame though, it says you're not allowed to do that because this thing has length 32 and the other things have length 31. Okay. So that's what happens there. Okay. Okay. So that's so data frames are stored internally as lists, and you can manipulate them as lists. But there are rules, right? As long as it's class data frame, basically this assignment function goes through and says, you know, I've got to make sure that everything's going to remain the same length. Okay. All right, is that good for data frames? All right, let's talk factors. All right, so factors we use to represent categorical values. All right, so here I've got some character vector called gender, and we've got M, F, F, X, M, and F for male, female, and either not specified, non-binary, something, okay? And we can turn this into a factor, right? So you take a character vector, you make it a factor, okay? And so when you say, show me what's the gender factor, it looks like this, M, F, F, X, M, F, right? And so one thing that clues you right away that it's a factor is obviously that there it says levels, okay? Anytime you see levels, that's going to be a key that it's a factor. And then the other thing that lets you know it's not a character vector is that there are no quote marks, right? So anytime you've got a character vector, you always have quote marks around the things, okay? Here there's no quote marks, so that's an indication right away that this is not a character vector, okay? All right, the levels, when you ask for the levels, that's an attribute of the factor. The levels is this vector, this character vector that says f, m, and x, okay? Which means there are 3 levels, f, m, and x, and this is what we see. So, and I think you guys said this already, if we ask how is the factor stored internally in R, it is stored as a integer vector, right? So if you say type of on the gender factor, it's going to say integer. Okay, so just quick quiz here. If I say as numeric or as integer on the factor, what is this value here going to be? The m, f, f, x, m, what values will I have?
0, 1, 2.
Well, I'm going to have something length 6. So what is the m?
2.
The m is going to be a 2 because when we look at the levels, m is the second value, right? The f's become 1 because it's the first level. So it's going to get stored as 2, 1, 1. X is 3. So we got 2, 1, 1, 3, 2, 1. Okay? And indeed, when I do this, right? So if I say as.integer, I get 2, 1, 1, 3, 2, 1 for the m, f, f, x, and m. So looking at this, and again, we can look at the attributes of the gender factor, and we have f, m, and x as attributes, and then the class is going to be factor, although it got cut off here on the screen. Okay, great. Factors are used for categorical variables, and because it encodes things as integers, sometimes it will do some weird stuff here, right? So here I've got x. This is a numeric vector, 0, 1, 10, and 5. It's a type double numeric vector, but I could turn it into a factor, right? Okay, so if I do this, okay, then I get this factor 0, 1, 10, 5. And then if I ask for the mean, what does it tell me? It tells me warning, in mean, argument is not numeric or logical, returning NA, okay? As it should, okay? That's a good thing, all right? Because does it make sense to take the mean of a categorical variable? No, right? If your categorical variable is something like hair color, and we have people with black hair, brown hair, blonde hair, and red hair, and we say, okay, what is the average? What's the mean hair color? That doesn't make sense, right? It doesn't. You can't say like brown plus brown plus brown plus blonde plus black divided by 4 is hazel. I don't know. Okay? It's not going to work, right? So it doesn't make sense to take the mean of a categorical variable. But here we've got something that looks like numbers, but is actually a categorical variable. Can you guys think of a categorical variable that looks like numbers? Because these exist. Categorical variable that looks like numbers. Yeah. Earthquake magnitudes. I would say those are still numeric, okay? Because it's on a log scale, but it makes sense to say this earthquake was an 8, this earthquake was a 7, the 8 is more powerful than the 7, okay? That makes sense, right? So, so anytime you can make a comparison between two quantities and say this one is bigger than this one, and therefore it's got this meaning, this interpretation, like this person is 35 and this person is 32, this person is 3 years older than this other person, that's going to be a numeric variable, okay? That makes sense, okay? I think somebody was raising their hand over here as far as, okay. So any ideas for categorical variables that look like numbers? Yeah?
If you sort the class into groups and it's like 5 groups, 1, 2, 3, 4, 5.
Okay, yeah, if we arbitrate, like if the labels we give are numbers, then yeah, that would be a categorical variable where the labels are numbers. And we could have easily just have used, this is group A, group B, group C, group D, and we would recognize like, okay, it doesn't make sense to take the average of these letters. But in this case, the labels happen to be numbers and things like that. Very good. Okay. Another example I was going to say is your area code. Okay. So you've got a phone number and an area code. All right. Your area code might be 310. Your area code might be 562-818 or something like that. Right. And if you say this person's area code is 818, this person's area code is 310, it doesn't make sense to say this person has 508 more area code than this person, right? That kind of comparison between numbers and saying this area code is larger or higher or more valuable than this area code just doesn't make sense, okay? And so that's what we have there, okay? So same thing with zip codes, okay? You can't take this zip code 90095 and I don't know what's the Westwood zip code, surrounding zip code. It's something else, right? Okay? And Beverly Hills 90210. You can't just take two zip codes and take a difference and say, okay, Beverly Hills has 200 more zip code than this, okay? That again doesn't make sense. Those are categorical variables. It doesn't make sense to take the mean or the average or something like that. And so when you to ask R to take the mean of a factor, which R says that's a categorical variable, it's going to say, I can't do that, right? Which is good. But you might be stubborn and say, no, I want to treat these as numbers anyway, okay? And so I would argue that star ratings for products on Amazon are technically categorical. Like you got 5-star, 4-star, 3-star, 2-star. It does make sense to make comparisons and say 5 stars is higher than 4 stars, which is higher than 3. But taking the average, I don't know if that makes sense, because I don't know if the difference between a 5-star and a 4-star product is the same difference between a 4 and a 3, which is the same difference between a 3 and a 2, which is what these numeric numbers would imply, right? So I've got some questions, right? But and then there's the whole problem with people writing fake reviews, and that's something else, okay? But you might be stubborn and you say, well, these look like numbers. I want to treat them as numbers, and I want to take the average, right? So what is the average of 0, 1, 10, and 5? You want to say I want it to say 4, but if you say as numeric for the factor and say take the mean of this, it's going to spit back 2.5, okay? So what's happening is that the factor, which is 0, 1, 10, and 5, is actually stored internally as integers as 1, 2, 4, and 3. The 0 is the integer 1, the 2 is the 1 is the integer 2, the 10 is the 4th level, and so that's stored as an integer 4, and the 5 is stored as the integer 3. And so the average of this is 1, 2, 3, and 4, 1, 2, 4, 3 is 2.5, okay? And that's probably not what you were expecting. So you should never do this as numeric factor and then take the mean, okay? That's going to give you a meaningless answer, right? If you insisted on doing something, you could do something like this. You can turn the factors into characters, and that would use the levels, and it would turn it into character 0, character 1, character 10, character 5. Then you can convert that into numbers, 0, 1, 10, 5 as numbers, and then take the mean. And indeed, this adds up to 16. 16 divided by 4 is 4. Okay, so that works. But in general, factors are reserved for categorical variables, and in general, it does not make sense to take the mean of a categorical variable. Okay, other rules about factors. You can't combine them, right? So AB combined with the factor BC, A gets turned into 1, B gets turned into 2, and stuff like that, okay? If you try to use so here we go back to the gender factor, and if you try to use a value that's not one of the allowed levels, it gives you a warning and puts in an NA instead. Okay. Coercion happens all the time. R is a dynamically typed language versus some language like C, which is strictly typed. And so it's going to just coerce things into the type that it wants to do, right? So here I've got a logical vector of true, false, integer vector of the integer 1, double vector of 5, 6, 7, and character vector of AB. And so if I combine logical, integer, and double, it's going to coerce everything into type double. And if I take logical, double, and character, it's going to coerce everything into character. And the way it works is it looks at the least restrictive type, in this case, which is character, and the most restrictive type, which is logical, and it goes, it picks the least restrictive and it coerces everything to that. So in this case, if I combine the logical integer and double, that logical, which was true, false, gets turned into 1, 0 for the type double, okay? Whereas if I convert them into character, that logical true, false gets turned into the character strings true and false, okay? And again, it tells me that it's type double and type character, as expected. Right? Coercion happens on the fly without R even complaining about it. So here I've got a logical vector that says false, false, and true. If I say make this numeric, it's going to turn it into zeros and ones. If you can say the sum, and it will say, okay, you have one value that was true. You can take the mean, and it will give you the proportion that's true. Okay, and this is very, very convenient because you can just take a data frame, do some kind of operation, and say, you know, here's the column of gender, and just say, what is the mean of gender equal F, okay? And then it's going to automatically turn that entire column and create a vector of true and false values from there. And then the mean, it's going to turn everything into zeros and ones, and it'll give you the proportion that's F, okay? And so, so that's very convenient. You don't have to do any kind of type conversions. You can explicitly coerce things using the as functions, the as.character, as.logical, as.numeric, and do any of these things, okay? So if you do as logical on 0, 1, you get false true. But you know, if you give it something that doesn't make sense, like turn the word cat into a numeric thing, numeric value, it says I don't know what to do with this, okay? So if you use as logical, 0 becomes false, any other value becomes true, okay? 1, -1, 0.1, all of that stuff, everything else becomes true, okay? For as logical from a string, these are the accepted spellings for true and false, okay? So these become true and false. Anything else will become NA. So if you use lowercase f and you do an as logical on that string, it's going to say NA, all right? FT and cat all turn into NA. What happened with the 0 and 1? Why did the 0 become NA and the 1 become NA rather than false and true? Yeah. It got coerced, right? First I combined them with the string variable, or the character vector, and so these got coerced into the character 0 and the character 1, and then when you tried to as logical, the character 0 and the character 1, those become NAs, okay? All right, this is a homework question, but here's your answer right here. What's the difference between NA, null, and NaN? NA is for missing or unknown values. Null is for non-existent values. That's different from missing, right? Missing means we know there's a value, we just don't know what it is, right? So it's like you've collected data, the person didn't answer the question, they didn't answer how much they weigh. You know the person has a weight, okay? You just don't know what it is, okay? And that's different from null, which just means it doesn't exist, okay? Like, is there a dimension on this atomic vector? That doesn't exist, okay? Okay, NaN is used for things that should be numbers but aren't numbers, right? Like if you do something like 0 divided by 0, okay? Well, not should be numbers, but 0 divided by 0 is undefined, right? And so, you get NaN, you get not a number, okay? NA is special in that this is one thing that makes R very unique, and this is why statisticians love R, okay, versus any other language, because I don't think any other language does this, is that you have an NA type specifically for missing data, right, which is a very common occurrence for statisticians. Anytime you have data, you might have missing data, and there is a different NA type, okay? So the regular old NA, this is a logical type, okay, so that you can throw the NA into a logical vector, and it remains logical, okay? But because you have atomic vectors and everything in a vector has to be of the same type, when you throw an NA into a, say, integer vector, everything in that integer vector has to be an integer. And so there is a specific NA for integer type, and there's a specific NA for character type. Of course, when you print it on the screen, it all just looks like NA. But internally, because the atomic vectors have to be all of the same type, these NAs, the NAs in a character vector are of NA type, okay? Are of character type. If you want to check for NA, you cannot use equals equals NA. NA equals equals NA is NA, okay? You have to use the is NA function. Here's a question. NA equal 3. What is this going to return? False or NA? It's going to return NA, right? Because the question is, there's a value in this bag. We don't know what it is. And over here, I've got the number 3. Is the value in the bag equal to 3? And the answer is I don't know, right? The answer I don't know is represented with NA, okay? NA equal NA is the same idea. It's just, here's the value in the bag. We don't know what it is. There's a value in this box. We don't know what it is. Is the value in the box equal to the value in the bag? And the answer is, I don't know, okay? I don't know either value. I can't give you the answer, right? So NA, so is that, right? But if the question is, do we not know the value in the bag? Yeah, that's true, okay? And that's why also if you say, like, what's the mean of 1, 2, 3, and NA, okay? The answer is NA, because it's saying, John has 4 kids. He's got a 1-year-old, a 2-year-old, a 3-year-old, and I can't remember how old the 4th kid is. So what's the average age? And the answer is, well, I don't know. If you don't know the age of the 4th kid, I don't know the average age of all 4 kids, right? You can tell it, like, ignore the missing values. Okay. Null is the null object, okay? It has its own type. The null object is its own type. Type of null is null, okay? And you can ask, is it null? And that's going to be true. Is a null the same thing as a missing value? Okay? And the answer isn't false. It's a logical 0, right? So we say, is something, is it missing? But we give you nothing, okay? We haven't given you anything, right? The null is basically a non-existent thing, and so there's nothing to report. So the answer for is NA is either is a logical value true or false, but there's nothing to report because you gave me nothing to check. Okay, so that's that. If you do operations with the null, like if you do null plus false or something, okay, the plus turns everything into integer type, but again, so that's going to coerce the false into a 0, but then when you try to combine it with the null, you get a length 0 integer vector, right? So null, you can't do operations with the null, okay? And if you try to like include a null inside this combine, 4, 5, null, and 3, it's like including nothing, okay? So it's just a 4, 5, 3, okay? We've got some recycling things going on. I think you guys are familiar with this, but if you got the numbers 1, 2, 3, and 100, 200, 300, it does element-wise addition and element-wise multiplication. So 1 times 100 is 100, 2 times 200 is 400, 3 times 300 is 900, so on and so forth. And then when you do this, it's going to recycle, right? So 1, 2, 3 plus 100, 200, 300, 400, 500, 600, it will add 1, 2, 3 here, and then it recycles back around, and it does 400 plus 1, 500 plus 2, and 600 plus 3. Okay, and it's happy to do that. If you do the same thing here, it's going to do the same thing, but it's going to say, I want 400 plus 1, 500 plus 2, and then I've got this 3 left over. And it's going to do it, but it's going to give you a warning and say, are you sure this is what you wanted to do, right? So here it adds it, 1, 2, 3, 1, 2, 3. And here it does 1, 2, 3 plus 1 and plus 2, but it says, you know what, this thing is not an even multiple of this thing, so I'm not quite sure if this is actually what you wanted to do. So it gives you a warning. It just says double check that, that you've done this. Okay, I've posted homework under CCLE, under week 1, and be sure to check that out. You should be able to get started on it, and we'll see you guys on Friday. It's due 1 week from today, next Wednesday at 6 o'clock. All right, we'll see you guys then.